our main message here is this product-independent testing framework, which was said in the other room that you shouldn't build your own framework, but I will try to give you the reason why we decided to do. And one day, of course, our manager just shuffled by and said, yeah, we need more automation, more tools, more everything. But he was also kind enough to let us time, and we proposed a solution. We wanted to do something different, and we were allowed to. And this is the end result, this automation framework. So the background of this, that we are working with the automotive industry. We are doing front video camera system test at Robert Bosch. For those people from last day who were on Rob Lambert's presentation for the Ds, we have more than 100 of customers. We have a test base of 10,078 test cases, which we have to maintain somehow for approximately 100 and something, 103 customer variants, which is a software and hardware combination. Automotive industry has very tough standards which we have to fit to, and front video camera is really a complex ECU in the car, because a more simple sensor in the car, an ABS sensor, just has a couple of inputs and outputs, and it's really trivial to test those inputs and outputs. But when we are speaking about front video camera, which is doing lane detection, it's doing road sign recognition, it's doing automatic steering and broadcasting information about that, then you have to be more safety critical, so it's very important. But the ECU itself is very complex, because the input is mostly the video, which is very difficult to simulate. And at Robert Bosch company, we have anyway a high level of standards which we have to fit into. So we already had some existing tools at the company which we didn't want to throw away, but we didn't find any other tool which was suitable for our testing framework, or what this testing framework is doing. And I will briefly introduce how a test is defined and run. So you can see on this figure that it's starting from requirements. We are going behind the customer requirements, and then the tester sits down, who defines the test case itself, and then we move it to the execution environment, where we execute the test, evaluate the results, and put back the information to the test management system, whether it's passed or failed the test. And this is kind of the semi-automatic way, or the manual way as well, to do this. And this process, what we wanted to not fully automatize, but apart from the fact that test definition is still testers' work for the future as well in Robert Bosch, every other aspect we wanted to have it as an automated manner. We had a lot of tools available, I said, and we wanted to organize it into a kind of system, and we wanted to have a kind of modular solution which is working from the code itself, because we anyway had test automation already in place. So we wanted to use those information still in this new framework, so we built on top of that. And to demonstrate the problem what we had this, I cannot hit the target from here, so I don't want to. So there is a test management system in the in that part. I cannot use it. Which was kind of a central element of the test definition and test execution, because we were defining the test cases in the test management system, which is a bad practice, I guess, but that was the case. And then it was an automated test case, because we already had a keyword-driven automation, so we could convert those test scripts into executables, but it had many manual interaction, and you see those gray people. Those are all manual steps, which means that you had to copy a file, bring a disk to somewhere, you had to move the camera, put into a different computer or something, which was still placed for automation. And with this framework, we targeted this kind of automation, not the automation of test definition. And what we ended up with this highly modular framework is that we designed a front end, which is called RAT, that will be introduced by Balázs. it's the shortening for Rapid Automation Toolkit, which is a web-based, cloud-based solution for every controlling aspects of our test automation. But the basic message of this figure is that from now on, testers should have to interact only with this singular web application, which is doing every other aspects of the testing, using the already existing tools which we had. So we're still using the same keywords, but they are assistedly parsed into this system, and the test execution is fully automatic in dedicated hardware. We run the test, and the test is automatically uploaded to the cloud with the results back to the test management system. And this is the architecture of this. On the top, there is this blue, bigger box with those smaller. So basically, that is the RAT server, which is responsible for providing the user interface for test definition, and all the file-related operations are working on that infrastructure. And with this small boxes to the right side, you can see that one is in our case, it's a standard Jenkins server, but any other automation server can do the same stuff. And what you see to the very left is the configuration management system, which is linked to this RAT application as well. And the Jenkins is connected via interfaces to the to the test management systems. What we use at the company, we use DOORS, RQM, but basically whenever we want to change it, we just have to define a new interface, and that's why it's modular. And a very important part of this structure is this environment development, this green part, which are the test execution machines. These are these dedicated hardwares. And there is another code which is not introduced here because it would have been a too big presentation, but there is a code running which is handling only the operative aspects of the test execution. So it gets the instructions from the RAT server, and it is running the test and providing every other steps. So I would like to give the floor to Balázs, who will kind of introduce you via the user interface or the user experience of this RAT tool, how it is working and what it's doing. And maybe you have more insights of this test automation tool that we have at the company. And later on, if you have questions, we can answer it even on the corridor as well.
Thank you, Gar.
Thanks.
So I would like to introduce yourself the user interface, because we thought that every aspect of the automation is hidden from the user. So if you were a user, you would also only see the Rapid Automation toolkit. So that's why we thought that we will introduce it to you. So first thing first, Rapid Automation tool in details. We like to get a solution which is easy to access, it's reliable, and every testers can access the well-known parts of it. So create a new test, run my all previously executed test, and see the results. That's why we integrated all of them into one user interface. The concept of it was that on this interface we can present the users, present the testers, the results, and also all the information necessary for the new test to write. That's why we also created an IDE-like approach, which helps for the testers to create new test. As you can see on the images, the web tool helps you by providing the keywords. We approach our testing as a keyword-based approaching, which means that we basically use functions. There are functions somewhere, but the tester doesn't exactly see them. But if I want to wait a signal or wait some time or check if the result is, I don't know, like 3, then we have keywords for it. And as you can see, all the keywords have different parameters and attributes, and all those are generated from the code behind it. So if one customer, as Kara said, we have a lot of customers. If one customer supports, I don't know, 1,000 keywords, and the other supports another 1,000, then by simply changing the customer on your rapid automation tool, then you will change all these information, and you will write only according to those customers. Why it's traceable? It's traceable because there is a linkage in the configuration system and also a linkage to the test management system, which means that every test which we present and say, okay, it's a test, it's not just a draft, then it will have an ID. Currently we use doors, but as Kari said, it can be switched to any other background process. Yeah, there's also, when a test is executed, then there will be, so it will run on different machines, and those are very scalable options, because if you have for example, a customer is now not needed so many tests, then we can only have one computer running for a customer's test. But if it's very time limited, okay, we now need every test for the next days, then we can scale it by applying more computers to that customer, and the user doesn't see it, so the tester doesn't see it, he just pressed execute, but yeah, that was our goal, so it's a good thing. Okay, so how is it done? So as you can see, it's done asynchronously, because in the GIF, you can see that an example of something running in the background. The red, yellow, blue stuff is our rapid automation tool, and the other one is just a normal Jenkins. That is just an example. That if I press something on the user tool, then it will be executed sometimes later asynchronously on our Jenkins server. Organize and re-execute tests. As I said, we can change customers, we can change users, and all this information is saved on our own database, which means that we can create queries, whatever we like. So if we want to list all the tests created by John Doe, then we can do that. If we want all tests created by John Doe in customer A, we can also do that too. So it's very intuitive for the testers, and also it's useful for managers to see how much test coverage, just how many tests was written. And as you can see, it's also just an example for the IDA functionalities that if a function or a keyword expects a number, then it's also help the user to not write something silly. And also it's easy to create multiple test steps. So if you have something but you want to modify only one test, then it's also programmed and done. What did we gain with its implementation? So I think first that we now have a higher likability, bigger willingness from the testers to test. So previously, everyone should know from their head how many keywords and which keyword is supported by which customer, and it was very hard and very time-consuming for each tester to remember all these stuff. And testers tend to use very small amount of keywords because it was easier to remember them. But now we can see that with a bigger willingness, our available keywords are well more used. It's an easy and convenient API interface, so I think it's very good for them. And also, home office was never possible for us because we had to sit in our computer, but it's now also possible because we can write our test from the distance. It's not running on our computers. So, as a summary of everything you said, our test automation framework is highly modular and automated, and the main message that you should go home with that you can that you can create your own tool for your own needs. Because if you have time for it, and if your manager support it, but otherwise it could be a very hard thing to do. And yeah, I think that's it. So thank you for your time. And if we have questions, then we can answer them both with.
Thank you. Thank you. Please use your app and send your votes. And right now we are jumping to the questions.
Okay.
How many keywords do you have? How hard is to maintain those?
How many? I don't know.
We have close. Is it working? We have close to 178 now, but it's quickly growing. We try to limit those because these keywords. If someone is not familiar with this, like Lego pieces of soft code snippets, which you can use by calling the keyword and giving a parameter that wait 5 seconds, and then the rest is done by a complex code. But you use this pseudo code to define your test. And now we have more than we expect to have. We try to limit the number to a low, because we would like people to be able to use it. And now we have this assistive technology, which we implemented, but even though with this 178, it's very difficult to deal with it.
But also one thing is here that we would like to have keywords, not like do a full test. That's one keyword. We wanted the keyword to be as small as part of possible. So that's why this is a small amount, but it's still larger than we expected.
All right, the next one. Why did you decide to use a web interface instead of a fluent keyword-driven test definition in the IDE that could be version controlled?
Yeah.
This could be version controlled also, because it's a web-based thing. So if you write, I don't know, press F5, then it will refresh with the newer version. But
no, we had this before, and the experience was that testers are still human beings. So even though they should have started with getting the fresh version of the actual keyword converter, which is converting the pseudo code into running test. They just never do this. So we decided by brute force that it's going to be a web-based application, because there's only a single update line. So when I update something into the PHP code, it's going to be updated for everybody in that second. And we don't have to send emails to update. We don't have to wait for. But there was a lot of problem with this version control that we had before, if it's answered the questions.
Mm-hmm. The next one. Did you use Jenkins only for scheduling the tests or for any other purpose?
Besides test scheduling, we also maintaining the database is also scheduling. So every day, and I think every 5 minutes or so, we try to use the freshest code of the software we testing, and I think that's all we use.
And in a broader sense, in the company itself, in some project, the developers use it as the continuous integration system. So for doing the build and doing the unit test after, but that's not our server. We have a different one. We use it only for this execution of the tests. It's very easy. We use the PHP to generate the command line, which we just use as a gateway, the Jenkins, for the different projects to link those projects to a dedicated hardware. So that's what we use for. And these additional features that getting information from the database regarding that the new keywords are there or not, or things like this.
Okay. Do you test framework?
Continuously, yes, because we're still developing this tool. So let's say what you see now, it's the 0.65 version. We're now on the 0.79. So there were a few releases meanwhile, and we test every feature because we are testers, so we immediately get the feedback from the colleagues. We are, at our department, we are close to 50 testers who are working on this 100 kind of customer variants project. So yeah, we have a lot of feedbacks and bugs.
Okay. Do the testers participate in the development of the under the hood code, or are they just use it as is?
You mean the keywords? I think the question was meaning that the keywords is, and yes, so every keyword is come from an experience, and the tester have like, oh, I need to have continuously measure something that this is 3 all the time, or during the measurement, and then he come to us and said, okay, hey, I have this code snippet. Can you help me extend it so it can be used in a wider sense? And then we help them, and then those are the keywords that you can use at our group currently. Yeah.
Okay. What are you using for test management?
Currently, there is a diverse selection of tools, which is also one of the reasons to have this framework, because the old projects are, there was a code invented in probably 1940-something, which is called IBM Rational Doors. And there are some heritage legacy projects which are still, we have to use that. I don't know if you have any experience with that, but that one is a quite tough software to deal with or live together with. And one of the main reasons we decided to go with the web interface and this centralized solution and a kind of building of a firewall in front of the test management system, because in the new generation project they shifted to different tools. I think in video development, what I saw once, it was also the new version of the IBM product family. It was maybe RQM or ALM or ALRQM, something with these abbreviations. And that's one of the reasons, because in 2 years maybe we have to have a new customer with a different test management. So sometimes, since we are shipping the product to customers, we have to work together with their technology. So if a random car company is coming to Bosch and they want to buy this front video camera system as a software and hardware bundle, maybe we have to use some very exotic tool chain, and then or a tool, we don't have to change anything, we just have to write the interface in front of the test management system, this new exotic one, and then everything is the same from a tester's perspective, and that was the main goal.
How easily can you fit your framework to different projects with all the configs?
Yeah, so that was the exactly thing that Kara just talked about. That we try to have every part as modular as possible, so we can change the test management tool, we can change the tester, code management tool, we can also change the Jenkins to the scheduling server if it's not supported anymore. And that was our goal, that we can use this as for different projects and different.
And it's also the reason we call it framework, because technically speaking, in its state now, it's not a complete framework, but it has the potential to be a comprehensive framework. Now we have the drivers for all stuff. If someone is interested, then probably it's possible to extend further this tool.
Mm-hmm. How much was it to develop Red?
Money or time?
Financially? Financially, we don't know.
No, actually, we have a group of 8 to 10 people who are quote-unquote automation experts. Balázs is one of those, and I am the group coordinator. So we spent probably 6 months just to have a decent plan on how do you want to do it. We had object diagrams, we had the database model, we had the use case scenarios and schematics and everything. And we went to the managers and we discussed, and finally the decision was that they hired 2 experienced coders. And these 2 guys one was responsible for this RAT tool, and the other one is for the everything other, which is the environment and this TAC, which we didn't have time for, this test execution software. And the whole development process was 8 months plus 1 additional month to bug fixes and stuff for these 2 guys.
I think only have 1 question because we just run out of time. What was the main reason to choose developing your own tool instead of selecting one from the market?
I try to list a lot of them, but the main thing is that we already had our own development. So the tool which is converting the pseudo code, so converting the keywords into decent function calls in the simulation and test environment, was already ready. We didn't want to change. We didn't want to buy a new one and spend any money on that one. And we evaluated, we did a market research, and we found a few solutions which were something like too big of a thing. So it's like if you just have to write some notes, then you're not buying a Microsoft full-fledged Office product. And that was exactly the case. And neither of the tools were perfectly suited for us, and it contained much more things that we needed. And some of them was missing what we really needed.
All right, so we are out of time, so László, Zsolt, Tamás, and all the others, please reach out to the guys during the coffee break and have a really good conversation with them. Thank you, Karen, Balázs. Enjoy your coffee break. Thank you.